seems like we already did this before. We've done small numbered ones, right? But now we're going to do operations, which means doing the math with small numbers. For example, what if you have this 2.4 times 10 to the negative 8 times 2 times 10 to the negative 2. Now let me remind you, if you weren't doing this in scientific notation, this is what this would look like. 2.4 times 10 to the negative 8, what is that in standard form? This 8 tells you what? How many places you move the decimal backwards. So I'm going to have to move it one place here and then add how many zeros? 7. So that first number is actually 1, 2, 3, 4, 5, 6, 7, 2, 4. That's my first number, not in scientific notation. And I am multiplying that by, this is 2 times 10 to the negative 2, so as a decimal that would be one place there plus 1 0. 0.02. Okay. So you could do that. It's not going to be that difficult. It is actually going to be 48 times 24. With how many decimal places? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, so can you just go if there's 9 zeros in front of that? Then I would have to change that back into scientific notation, which would be 4.8 times 10 to the negative, how many places do you get back there? 10, right? There's 10 jumps. 1, 2, 3, 4, 5, 6. But you don't have to do any of that because just like with multiplication of big numbers, it's a 2-step process here, or 3 if you're unlucky. Okay, the first thing you do is multiply the 2 left numbers together. What is 2.4 times 2? 4.8. Hopefully we can do that. That's step number 1. Step number 2 is you write times 10. And step number 3, how do I know what my exponent of 10 is? I got these two I'm working with. What do I do to those? Anybody? Grace is going to say it. I could see she's almost mouthing it. What do I do, Grace? Yes. You plus them in second grade lingo. Negative 8 plus a negative 2 is negative 10. This same answer I got when I did really all the long stuff over here. It's the same thing that you did. We've done this before, so it's not that bad of a deal. Remember though, you have to make sure when you do this, your answer has to be in scientific notation. Or else you need to change it to scientific notation. Let's do a division one, because I can tell you're fancy about that. Yeah, here's going to be a good one. How about this one? Do a hard one. 8.1 times 10 to the negative 4th over 3 times 10 to the negative 7th. Now this is division. So my first step is going to be what? Cameron Colquitt? The left side. Anybody tell me what 8.1 divided by 3 is right off the bat? Elijah Fisher? It is 2.7. You still always put times 10 in here. Now the tricky thing. With multiplication, you added exponents. With division, you subtract. And here's where you have to be careful. I have a negative 4 and I am subtracting a negative 7. What happens when you subtract a negative 7 and those two negatives are together? It actually ends up being an adding 7. Negative 4 plus 7 is a positive 3. And Shazam. Subtracting a negative is the same as adding. Because you're taking a deck away, more or less. I need one where I can change numbers here. Yes. One more. 1.2 times 10 to the negative 8. 1.2 times 10 to the negative 8 over 3 times 10 to the negative 4. What do I get if I divide, 1.2 divided by 3 is, Brianna? 0.4. I can do that for you. Let's do it just in case you're missing that. Nothing above the 1 because 3 doesn't go in 1, but it does go in 12. It is 0.4 times 10. Same thing is true here. When I move this, it is negative 8 minus a negative 4, which actually means negative 8 plus 4, which actually gives you what, Jaden? Negative 4. Negative 8 plus 4 gives you negative 4. This is not correct yet. Why? Because it's not in scientific notation yet. Why not? Because I can't have a 0.4 as my number. It's not between 1 and 10. So remember what we do? Change the number so it is between 1 and 10, which would mean I'd have to move the decimal here. This becomes a 4. But if I change this, my exponent changes. What happens to Mr. Exponent there? And you got to think about it like a little seesaw balance thing. If you make this one bigger, you have to make this one smaller. What is 1 smaller than a negative 4? Kamar? Exactly, it is negative 5. 1 smaller than a negative 4 is a negative 5. And that would be this in scientific notation. Much easier to do than if you're trying to work with all those numbers with all those zeros put before it. It gets a little confusing and crazy. Look in your books page on please 391. At the very top of page 391, read it to yourself as I read it aloud. Don't spend any too much time on one question. Letter I says a dollar bill weighs 0.0001 kilograms. That's about the weight of a dollar bill. What is the weight of $1 million bills? Okay. Now here again, if it says to use scientific notation, and here's where you need to figure out, am I multiplying or dividing? Okay, you need to figure out what operation you are using. And when I do this, because the decimals and the big numbers kind of throw me for a loop, I just in my mind go, okay, what if a dollar bill just weighed 1 pound each and I had 10 of them? If a dollar bill weighs a pound and I have 10 of them, how much would that be? 10 pounds. What did you do, multiply or divide? Multiply. So that's what you're going to do with these. You're just multiplying them together, but they want you to do it in scientific notation, so you have to end up doing 1 times 10 to the, what power is this going to be? Move it over 3 places, negative 3. You're multiplying that by 1 times 10 to the, what power? 6, because you move it all the way there. And then your math is pretty easy. It is 1 times 1 is 1. Add those two exponents together, you get 3. And there's your answer. 1 times 10 to the third power, which is actually what? 1,000 pounds. Oh, kilograms, sorry. I don't want, yeah, well, it's actually more because there's 2.2 kilograms in a pound, it's a ton. $1,000,000 $1 bills would weigh close to a ton. Well, it'd be over a ton. It's a metric ton. 2,200 pounds. That was exciting.